This part is on using rates of change. So in this section, we're going to try to utilize what we've learned in the previous part, 8.1.1, to do some questions that are more likely to be in your school exam. Okay, so watch very carefully. Question 5. The number of people is PT, so it's P in terms of T, that's all it's saying here. It's given by that. Okay, so that's the number of people expression, where T is the time in years and after the year 2000. And make sure T is going to be between 0 and 8. Okay, so they give you very specific information here now. T is in terms of years, okay, and that's going to be after after the year of 2000. Okay, so keep that in mind. Now part A, find the number of people at the year 2000. Okay, well at the year 2000 is when the time is 0. Okay, so when, because T is the time in years after the year 2000, 2000 is just 2000 plus 0. There's no years after that. So T is just going to be 0 at the year 2000. Okay, so I've put in T equals to 0 into this expression, so sub in 0 into all your T's and you should calculate as 30,000. And that's it. So that's the initial amount of people basically. Okay, so that's the number of people when T equals to 0. Now B, find the number of people at the year 2008. Now here guys, how many years are we adding to 2000? 8. So T is 8 in this case. So we sub in 8 like we did in this question, but this time 8. So sub in 8 into all your values of T and calculate that. That's what you should get. Just a bit of calculation for you to do, so just double check that. So that's your answer for this one. So see how it's increased a little bit? Now C, find the rate at which the number of people is changing when T equals to 2. Okay, so make sure you're understanding what the question is asking you to do. It's asking you to find the rate. Remember, rate of change is when we differentiate. So we must find P dot. That's when we differentiate P, isn't it? So you differentiate that, easy differentiation, just differentiate in terms of T, and just check you got that one the same as me. And it says we want to find the rate of the number of people changing at time 2. So I simply sub in T equals to 2 into this expression. So see how I subbed in 2 into T? Calculate that, you should get 256. Okay. So part D will link to question C. It says describe the significance of the result of part C. So it's asking what this number is indicating. Well, the 256 means after 2 years, because they say T equals to 2, so after 2 years the number of people is increasing by 256 people per year. That's what the rate of change is. Okay, because when we differentiate, it tells us the rate of change. So in this case, we're talking in terms of number of people. So that's why the indication of this result that we had, 256, is the rate of change of the number of people. So it's increasing by 256 people per year. You must understand this because the exam questions in your school exam will directly ask you this. So you've got to be able to write in words what these numbers indicate. Okay, so make sure you understand before you proceed. Now E, find the rate at which the number of people is changing when T equals to 8. Okay, very similar question to the previous. So I'll do the same thing. We know that that's P dot we got in the previous part. And this time I want to find the rate of change when T equals to 8. So just sub in 8 into T, just like that. And you should get negative 896. So that's the answer, just to double check for me guys. And you know that the preceding question will be, describe the significance of the result of part E, which means, what does this number you had in part E indicate? What is it talking about? So think about it guys, you should think about it by yourself first, and then check with mine, okay? So what do you think this indicates? Well, it's negative. So this means after 8 years, because T was 8, right? The number of people is decreasing. The key thing here is decreasing, whereas the previous one it was increasing, wasn't it? This time it's decreasing by that number, 896 people per year. Okay, so it's always going to be per year, because remember how it's going to be always the number of people in terms of years. So just remember that. And the key thing here is that it's decreasing because of that negative. Okay, so do you get the idea, guys? It's repetitive, isn't it? So that was part F of question 5. Now G, find which year the maximum number of people occurs. Okay, we're going to find the year. So we have to find T when the maximum number of people occur. So how do we know that? Well, the maximum or minimum will occur when P dot is 0. P dot in 0 means that the rate of change is 0, which means there's no more people increasing or decreasing. So it stops. It's the point at which the rate of change stops. And you also know from your applications of calculus that P dot, P dot, I told you it's differentiate P. When you differentiate something and you let it be equal to 0, you can find the stationary points. The stationary points indicate minimum and maximum points, don't they? So it's the same knowledge here. To find maximum or minimum points, you simply differentiate P and then let it be equal to 0. Okay? That's all I'm applying. So just the applications of calculus, you've got to really have a good knowledge in order to do this class, in order to do this whole topic. Okay? So that's what I'm going to do. And we found P dot in one of the previous sections, haven't we? So that's the P dot that we've differentiated P. And we're going to let it equal to 0. And we're going to find T. So I'm going to differentiate by the common factor of 4T. And you can see that I can differentiate this further like this because it's a difference of 2 squares. And therefore you can say that T equals to 0 from there. And T is going to be positive 6 or negative 6. So plus or minus 6. Okay, so I have 3 solutions of T. But you know that, guys, it tells us here T must be between 0 and 8 inclusive. So we can't have T equals to negative 6. So I'm only going to have T equals to 0 or T equals to 6 because time must be positive, okay, because of this as well. So that's what it's saying here. So that's what you're going to consider. So we're only taking those 2 values. So out of those 2, we're going to find which is the maximum because they want the maximum. Okay, so in order to do that, we're going to double differentiate and find what those values equal to. So double differentiate P, so I just differentiate P dot one more time. That's what you should get. Just do your usual differentiation, calculate it and just check with mine. And I'm going to sub in T equals to 0, which is my first value of T, and I get 144. So just sub in 0, you can do your own calculation and you should get 144. Now that's greater than 0. Now let's try T equals to 6. When I sub in T equals to 6 into T, I get negative 288, which is less than 0. Guys, you're going to be able to tell me straight away which one indicates the maximum point. It must be this one here. When double differentiate is less than 0, that is when the maximum point occurs, right? You should all know this, definitely. So therefore, the maximum occurs at T equals to 6. So therefore, at the year of 2006. Because T, again, as I keep repeating, is a time in years after the year 2000. So we simply add that 6 to 2000. So the specific year is 2006. Okay, so that's it. So you can realize that a lot of that applications of calculus is relevant in this topic, right? So make sure you have a good understanding of that. Now H, find the maximum number of people. Okay, well the maximum occurs at T equals to 6. We found that in the previous part, haven't we? So to find the maximum number of people, what should we do? We should sub it into this equation here. Because what does this equation tell us? It tells us the number of people. So to find the number of people at T equals to 6, make sure you sub it into this one, not anything else. Okay, so sub it in, put T equals to 6, calculate that, you should get that number there. Okay, so at T equals to 6, that's the amount of people that is there, okay, at this particular population. Alright, so specifically at 2006, this is the amount of people. Okay, so do you guys understand the context? You must understand the context of the question in order to understand every single question. So make sure you have a good understanding of the whole background of the question. Question 6. Okay, this time it says the volume of water in litres remaining in the cylinder t hours after it started emptying is given by this equation here. So this time make sure you know what it's talking about. It's talking about the volume of water in litres, okay? And t is in terms of hours. Alright, so the cylinder will have some water inside and it will be emptying, and we want to find, we don't know the question yet, but the volume will change depending on the time when it passed. Okay, depending on the time passed, in terms of hours, the volume will change because it's going to be slowly leaking out. So this is the expression that gives us the volume. And part A says, if the cylinder was initially full, find its capacity. Okay, first of all, what does it mean by capacity? Capacity is the maximum amount a particular object can hold. So in this case, the capacity is when the cylinder is full. Okay, so amount that in litres, when the cylinder is full, is its capacity. And it tells us it's full initially. So initially at time equals to 0, it was full. Okay, so it's going to start when the water is filled the cylinder. And I just told you, when it says initially, it means t equals to 0. You must remember this. For any question, if it asks your initial value, it's when t equals to 0. So I'm simply going to sub in t equals to 0 into this equation, just like that. And calculate it, you should get 225 litres. And that's it. So that's all there is for part A. So how easy was that? So all you need to know was sub in t equals to 0. Okay, so that was part A. Part B. Find the number of hours the cylinder is empty. So I want to find how long, in terms of hours, it takes for the cylinder to be empty. Because as I said, the water is going to be slowly, well, I don't know if it's slowly, but draining out. And then I want to find the number of hours that it takes for it to be completely no water. Okay, so that's what I want to find. So in this case, what would the volume be? I want most of you guys to be able to tell me that volume is 0 in this question, okay? Because when it's empty, there's no volume. There's no water, so volume is 0. So simply let this whole thing be equal to 0, just like that, and now it's your usual quadratic equation. And you should all know that this is a perfect square, so you can factorize it like that, because 225 is 15 squared. And you know that negative 15 minus 15 is negative 30, so it's a perfect square. So you factorize it like that, so therefore t is just 15. So 15 hours is how much it takes for the cylinder to be completely empty with no water inside. Okay, so that was part B. C, find when just 100 litres remain in the cylinder. Okay, this is pretty much the same as the previous question, but this time I want to find the time in hours, how long it takes for it to only have 100 litres remaining in the cylinder. So this time, let V be 100. That's all you need to do. And then move 100 over to the other side to let the equation be equal to 0. And again, it's your usual quadratic equation. Find the factors of 125. You should be able to do the factorization by yourself. That's what I've got, so just check with me. And therefore, in this case, t will be two values, 5 and 25. But does that make sense? Can we have 2 times? It's a bit unusual to have 2 times when the volume is 100 litres. And remember from our previous question, in the previous part B, we found that the cylinder is empty when t equals to 15. This is the outcome that we've found in part B, haven't we? So when the cylinder is empty, it's 15 hours. That's how long it takes. But when the time is 25 hours, does that make sense, guys? Can we have more than 15 hours for the cylinder? Because it's empty when it's 15 hours and we can't go over that, right? So 15 hours is basically the maximum time it takes, right? So therefore we can't have anything that's more than 15. So make sure you understand why. So therefore in this question only 5 is the answer. So 5 hours is how long it takes to have 100 litres. Okay, so make sure you get the last part. That's very, very important, and probably the part where you get awarded the most marks. Okay, so that's question C. Now D, find the rate of the water flowing of the cylinder when just 100 litres remain. Okay, so this time it says find the rate. So we want to find the rate of change of the water flowing, which means we must differentiate V. Okay, because remember I told you when I want to find the rate, I differentiate the expression of the particle. Okay, well this is not a particle, it's volume. So we differentiate volume in terms of the time t. Just differentiate that, guys, and just check you got that. Now, it says we want to find the rate of the water flowing when just 100 litres remain. Now, in the previous part, we found that t equals to 5 is when only 100 litres remain. So we simply sub in t equals to 5. So when I sub in t equals to 5 into there, you should get -5. So that's pretty much it. That's the rate of the water flowing. So to sum up, I can say that therefore the water is flowing out of the cylinder at a rate of 5 litres per hour. Okay, and guys, before you continue, why do you think it's negative? Because the water is going out. The water is not going in, the water is going out, so therefore it's going to be decreasing, so that's why it's going to be negative. And that's it. Okay, so that's what the negative indicates, so make sure you know what that's about. Okay, so it's a good idea to make a little conclusion in your answers. So that was part D. Question 7. The volume of water, V, so again it's about volume, so you should be pretty used to this kind of question, in litres at t seconds, so this time t is in terms of seconds, so keep that in mind, is given by that expression there. And t is going to be between 0 and 50. Okay, A, find the initial volume of the water. All of you should be able to tell me that initial means t equals to 0. So I'm simply going to sub in t equals to 0 into this equation, just like that. So just sub in 0 into there. Calculate it, that's what you should have. Okay? Now, therefore, initially, there was 100 litres of the water in the tank. So this question is like the previous question. This this initial volume of the water is basically the capacity of that tank. Okay, so that's what it's asking you to find. Now B, find the time when the water tank is 1/4 full. Now we know that when it's full, it's 100 litres. We found that in part A, haven't we? So when it's 1/4 full, simply divide that fullness, that 100 litres, by 4. So you should get 25. Okay, so this is just 400 divided by 4, which is 1/4. Okay, so this links to the first question. So you just let this be equal to 25 and solve for t. So I just divide both sides by 100 and then square root both sides and make sure it's plus or minus, not just plus. And plus or minus square root of 0.25 is plus or minus 0.5. And I'm going to move the 1 over, so I have something like this. I won't simplify, I'll just leave it like this. And then divide both sides by negative, because I don't want that negative out the front. So this will become positive, and plus or minus times negative is still plus or minus, right? So that's why that plus or minus remains. Okay, now calculate it. This is 1 plus 0.5 or 1 minus 0.5. I'll separate it so it looks a little bit more logical. And calculate it. And then to get t, we divide by 0.02 for both parts, don't we? So divide both of them by 0.02, you should get 75, and t equals to 25. So 2 values you have. Now remember guys, in this question, it tells you that t must be between 0 and 50. So we cannot have the 75. But you must tell me this, or tell your teacher this in your exam, okay? So make sure you eliminated the 75 because of this. Okay, so therefore, only 25 seconds. So 25 seconds is the time it takes for the tank to be 1/4 full. Okay, so that's the question, and that's the answer. That's part B. Let's move on. C, find out the rate that the water draining out when the water tank was 1/4 full. Okay, so this time the question is asking for the rate. So what do we do to find the rate? Yeah, you should be all able to tell me that we differentiate. So it's going to be V dot, which means differentiate V, isn't it? So you go ahead and differentiate that, guys. 2 times 100 is 200. Make sure you apply your chain rule, because you must differentiate that inside. So differentiate that and multiply to that. And this differentiate is negative 0.02. Multiply it all, you should get that. Okay, just some easy differentiation. I don't really need to go through that one. Now, when it was 1/4 full, guys, remember in our previous question, we found that it was 25. It took 25 seconds for it to be 1/4 full. So to find the rate at t equals to 25, we simply sub in 25 into this equation here. So sub in 25 into there, just like this, and calculate it on your own. You should be able to get -2. Okay, and that's it, guys. That's the answer to the question. That's all they're requiring you to do. But tell me, guys, what does that indicate? What does the -2 indicate? It's saying at 2 seconds per litre, it's going down for the volume of the tank. But why is it negative? It's because it's going out. It's draining down, so the value of that volume will go down. That's why it's negative. So make sure you understand that before you proceed. Okay, and that concludes question 7.